Today we're going to be talking about the Pythagorean theorem. I'm pretty sure you guys have probably seen this before. The a squared plus b squared equals c squared idea. You just may not be familiar with its name. So this is called the Pythagorean theorem. So the wording of the Pythagorean theorem, it says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So, when you're looking at a squared plus b squared equals c squared, it's important that you guys remember what the a, b, and c are referring to. So the a and the b, as illustrated in this picture, the a and the b are referring to the two legs. The legs of a right triangle are the two sides that create the right angle. And then the hypotenuse, which is always c at the other side of the equation, is going to be the hypotenuse, which is the longest side, the diagonal side, that's across from the right angle. It's important you guys remember that these two side measures, whether they're numbers or variables, those are part of the sum part of the equation, and then the hypotenuse is on the other side of the equation. Also make sure you remember to square them, because that is definitely an important part of the Pythagorean theorem's equation. Something I do want you guys to make sure you are aware of are things called the Pythagorean triples. There are three numbers that when you plug them into the Pythagorean theorem, everything works out neatly. So for example, 3, 4, and 5. If you were to take 3 and plug it in here, take 4 and plug it in here, 3 squared plus 4 squared is 9 plus 16, which is 25. That's the same thing as 5 squared. So a Pythagorean triple gives you three values that represent a, b, and c that work perfectly when you plug them into the Pythagorean theorem. So what I want you guys to do, it is a little bit of memorization, but you don't have to memorize a lot. I just want you to memorize this Pythagorean triple and this Pythagorean triple. So 3, 4, 5, and 5, 12, 13. So just remember those two. Something else that's important to remember is that it could be 3, 4, 5 or any multiple of those numbers. So let's say you take 3, 4, and 5 and multiply them times 2. So another Pythagorean triple would be 6, 8, and 10. It's based on the 3, 4, 5. You've just taken each number and multiplied them by the same value. So that's what I mean by any multiple in parentheses there. So just remember to memorize those two Pythagorean triples, 3, 4, 5, and 5, 12, 13, and then be aware that you can multiply those by any number in order to get an additional Pythagorean triple. There are infinitely many Pythagorean triples, that's why I'm not going to have you memorize all of them, but these are the most commonly used ones, so make sure you remember them. Alright, so the first page is going to be some work practicing how to use the Pythagorean triple to help us solve. So remember, it has to be a right triangle. If you don't have a right triangle, you can't use Pythagorean theorem. So if you notice in this picture right here, I have all three sides are labeled with either a number or a variable. That's the setup you want to look for to know that you're going to use Pythagorean triple. And then the best way to do this is to go ahead and label the sides with A, B, and C, so you know where they would go in the equation. So I'm going to call this A, this B, and then remember the hypotenuse, one that's slanted, is C. Now, I always have a student ask, does it matter which one's A and which one is B? And the answer is no, because in the Pythagorean theorem, that is commutative because it's addition. So you could write it a squared plus b squared or b squared plus a squared, and it wouldn't make a difference. So it doesn't matter which leg is A or B, just make sure you know the difference between the legs and the hypotenuse. So when I plug these numbers into the Pythagorean theorem, I would get 6 squared plus 10 squared equals x squared. Okay? Then I get 36, 100, combine like terms, and then remember to solve when you have x squared. To solve, you would take the square root of both sides, and I did here. Now, just like in any other scenario when we're working with radicals, you want to make sure that you have fully simplified the square root. So the square root of 136 is not a perfect square, so you're not going to get a whole number, but I do not want you to write that as a decimal. I want you to make sure that you simplify it like we've done before with the distance formula and other things like that. So the two numbers, remember the process is to find the two factors of 136, where one of them is the biggest perfect square that you can find. So if you were to split, it would be 4 times 34, is what I see in my notes. So 4 times 34 is 136. 4 is the perfect square. So in order to simplify the radical, you're going to take the square root of both 4 and 34 that becomes 2 because the square root of 4 is 2, and then the square root of 34 stays inside. All right. Again, we've been practicing simplifying radicals since the start of the year. If you're still struggling with that, make sure that you're going online or seeing me after school to practice that idea, because that will carry through for the entire year in geometry. So that would be the answer. Right, let's try the next one. So this time, I'm going to look, I see it's a right triangle, I see that all 3 sides are labeled with either a number or a variable. I'm going to go ahead and assign what parts they would be for the Pythagorean Pythagorean theorem, making sure I keep the diagonal, the hypotenuse, as C. So then I plug them in. So a squared, or x squared, plus b squared, which would be 4 squared, equals 3 square root of 2 squared. Okay? Now notice how I put parentheses around that. When your label, whether it's a number or a variable, has 2 parts to it, like a coefficient in a variable or a simplified radical like this, make sure that you put parentheses around that, because we're going to do something special with the square in a second. So on this side, it would become x squared plus 16 if I'm working it through. Now, when you have this kind of scenario where there are 2 parts to your term, you guys will have to distribute the square. You can only distribute powers if there's no addition or subtraction between the terms. So I notice that this is linked together with multiplication, so I can distribute the square. So this really becomes 3 squared times square root of 2 squared. Okay, the multiplication still stays put in that expression, or in that term. So it becomes x squared plus 16. Now, 3 squared is 9, and then I hope you guys are aware from Algebra 1, if you guys remember, the square root and the square cancel each other. That's the whole point of squaring, is to get rid of that square root. So this really just becomes 2. So the square and the square root cancel each other, leaving you with whatever's inside of the radical, which is the 2 in this scenario. Again, if you guys need to go back and review a little bit of your Algebra 1 working with radicals, you might want to do that, because we'll be using this concept from here on out to the end of the year. And so that leaves me with 18, and then I subtract the 16, I get 2. And then again, once you're here, all you have to do is take the square root. So we get x is equal to the square root of 2. And because I can't simplify the square root of 2, that would be my final answer. So just one more time, the extra step that's in here that you guys might be a little unfamiliar with is when you have something like this, you have to distribute the square, square both parts, and then multiply them together when you're done with that. Okay? All right, we have another one over here. I know it's a right triangle, so I can use Pythagorean theorem. I have a and b, and then the hypotenuse is c. So I have 3 squared plus x squared equals 5 squared. That gives me 9 plus x squared equals 25. X squared equals 16. You subtract the 9 over. Then when you take the square root, you get x equals 4. Right, now this is a perfectly valid way of doing this question. However, I will bring back the idea of Pythagorean triples to show you why it's important to know them. So if I saw this picture right here, and I saw that there was a 5 on the hypotenuse, and then a 3 is one of the legs, instead of doing this work, if I have the Pythagorean triples memorized, I can automatically go to say that's 4, because one of the Pythagorean triples was 3, 4, 5. So if I notice that I have a 5 and a 3, and they're in the right position, the 5 does have to be on the hypotenuse. If I see that, I can finish the Pythagorean triple that I have memorized and get it without even having to do the work. So that is one benefit to having the Pythagorean triples memorized. But don't sweat it. If you don't have them memorized quite yet, you can still use the Pythagorean theorem to get to your answer. So that's really just a shortcut using the Pythagorean triples. It's a shortcut. All right, so on the next one. Now what's interesting about this example is that it's similar to this one, that I have a 3, an x, and a 5, but I can't use the Pythagorean triple for this example because the 5 is not the hypotenuse. For the Pythagorean triple, it needs to be 3, 4, 5, with the 5 representing the hypotenuse, and that's not the situation here. So that is the downfall of trying to use the Pythagorean triples as shortcuts. You can't use it every single time you just see the numbers. They need to be positioned correctly within the triangle. So for this one, I can't use the Pythagorean triples, so I'm going to use the Pythagorean theorem, work it out. So 3 squared plus 5 squared equals x squared. I have 9 and 25. Gives me 34. I'm pretty sure 34 can be simplified. So when you take the square root, you just get the square root of 34. And you cannot simplify the square root of 34. Alright, next one up, here's another right triangle. I'm going to mark A, B, and then C for the hypotenuse. Then I have the square root of 5 squared. Remember that whatever A, B, and C are, you have to square that in the MD formula. So I have A squared plus B squared equals C squared. Now, coming back to the concept that I was talking about up here, the square and the square root are inverse operations, so they cancel each other out. So this term right here, these basically disappear, leaving you with just 5, just the number inside of the radical. Same thing here, the square and the square root cancel each other, leaving you with just 20. Then I get x squared. Alright, so these combine to get 25, and then it works out really nicely for us when you take the square root of 25, that is 5. Sorry, that's an equal sign. Okay, so again, don't forget that property that squares and square roots cancel each other. Alright, now we have this one. So this one's interesting because we have x in 2 different spots, but we can still use the Pythagorean theorem. Remember, you can use the Pythagorean theorem when you have a right triangle, and each one of your 3 sides has some sort of label, whether it's a variable or a number. So I have A, B, and then the hypotenuse is C. So I have x squared plus x squared equals, now remember the parentheses. This has 2 parts to it, so make sure you have it in parentheses so you remember to distribute. So this, when you combine like terms, is 2x squared. When you distribute the power, you're going to get 4 squared, which is 16, times the square root of 3 squared. Again, they cancel each other, leaving you with 3. So I took out a step from up here, but I'm doing the same thing. You distribute the power to both of those, and you keep them, they're still multiplied together. So I get 2x squared equals, what is that, 48. And then when you divide by 2, you get 24. I'm going to come up here to finish my work. Now this is something algebraically that a lot of students usually forget that I've noticed. When you guys are going to take a square root, you have to make sure that any coefficients in front of the variable that's being squared, they have to be divided away. You can't take the square root at this point because you can't really square root 2. It's not a perfect square. So make sure that when you're trying to solve for x, get that x term by itself before you take a square root. So make sure you divide, add, subtract, anything like that. You have to take care of that first before you take the square root. So now I'm here, I'm going to take the square root. Now the square root of 24 can be simplified. You're going to split that into 2 numbers. Remember, you want the biggest perfect square that's a factor of 24. And that would be 4. So 4 and 6 is how I split. Since 4 is a perfect square, I'm going to take the square root of that to give me 2. And then the square root of 6 can't be simplified, so the 6 stays on the inside of the radical. So your final answer is x equals 2 square root of 6. Okay? Alright, now this last row is, a couple of the questions are presented a little bit differently. Just so you guys can see the context in which you still would be able to use Pythagorean theorem, it just may not be immediately obvious. So like this one right here, I see that I have an equiangular triangle. I know it's equiangular because this angle is equal to this angle is equal to this angle. So remember, equiangular means that all the angles are equal. If you remember from when we were talking about triangle classifications, if all the angles are equal, that means that all the sides are equal. So for this triangle, we don't have enough information from the start to actually solve the question. And by the way, I accidentally forgot to put a little right angle here that was supposed to be in the notes, so go ahead and add that, because if this wasn't here, we wouldn't be able to solve using Pythagorean theorem. Because remember, it's for right triangles only. So that was my fault. Go ahead and put that right angle right there. It was supposed to be printed in the notes, and I forgot to make that edit. But back to what I was saying. So for Pythagorean theorem, you need to have the right angle here. You also need to have something written on all 3 sides. And so with this picture, I'm missing that 3rd side, this side right here in this right triangle. If you want to draw it off to the side, I have x, 16, but I don't have this 3rd side. So it takes a little bit of extra work for these kinds of questions to find any missing information that you may need in order to then apply it to the Pythagorean theorem. So for this one, noting that all the angles are equal indicates that all these sides are equal. So I can say each of the 3 sides would be equal to 16. But some other markings you need to pay attention to are these little congruency markings, which are indicating that this segment has been divided into 2 equal parts. And so if the whole thing is 16, that means that just one part of it, the side that we're looking for, would be 8. So I know the Pythagorean theorem, like for the questions above, it was really easy to just plug them into the formula and work it out. But you do need to be aware that Pythagorean theorem could be used in other situations that are a little bit more complicated, where you have to do a little bit of work before you can actually do Pythagorean theorem. So do make sure that you're able to apply that to these scenarios too. So once you have this triangle worked out, and it's a good idea to draw it off to the side with all the information isolated, I can now use Pythagorean theorem. So I have x squared plus 8 squared equals 16 squared. I don't have that memorized, unfortunately. 190. Oh, sorry. I took a step ahead. If you want to write out all the steps in algebra, that's fine, but I just went ahead and I found the square root of 16, and then I subtracted the 64 in one step. You guys can separate them out to 2 steps, but if you want to save space, you can go ahead and do the subtraction right away. I know a lot of you guys like to save space and jump some steps, as long as you don't confuse yourself this time. Alright, so when I subtract the 8 squared from the 16 squared, I'm left with this. I take the square root, and I get the square root of 192. Now, again, when you have a radical like this, you want to see if you can simplify it. So 2 numbers that you can use would be 64 and 3. So if you can test this in your calculator if you'd like. 64 times 3 gives you the 192. And because 64 is a perfect square, I can then simplify that to 8 with the square root of 3 left over for my radical. Okay. Again, keep practicing with radicals if you're a little bit shaky on that. Alright, 2 more. This one, I'm actually not going to do the Pythagorean theorem for this. I'm going to apply that shortcut I was talking about earlier with the Pythagorean triples. If you notice, this side is 15 and this side is 9. If you think to yourself about the Pythagorean triples, it's supposed to be 3, 4, 5 is the Pythagorean triple, one of them that I asked you guys to memorize. Well, the 5 is usually the hypotenuse, and if you think about 15, that's 5 times 3, right? And then this side right here is 3 times 3. So I can see I have the 5 and the 3, and they're both being multiplied times the same factor, 3. So I can use logic in my Pythagorean triple to then figure out that if I have 5 times 3, 3 times 3, then this side must be 4 times 3 to finish the Pythagorean triple. So it would be 4 times, x would be 12. Sorry, this is an equal sign. X would be 12 following the Pythagorean triple shortcut. Again, if you don't want to do the shortcut, you could use Pythagorean theorem. You could say x squared plus 9 squared equals 15 squared, and you'll do all of the algebra, you'll eventually get to 12. Okay? But that's just a way that you guys can use the shortcut to illustrate how you would show work and the thought process for using the shortcut with the Pythagorean triple. And we have our very last one right here. So what's interesting about this one is that we have our right triangle, but again, just like over here, I only have 2 of the 3 sides labeled, and I have to do a little bit of extra work to get that third side. So you have to look at this shape right here. It is a rectangle that's attached to this right triangle. So something hopefully you guys know about a rectangle is that the opposite sides are congruent. So if I know that this side is 3, that means that this side has to be 3. So that's just one thing you have to do before you get started, is to slide that 3 over. So I now have a right triangle, x, 3, and square root of 5. Once you have your right triangle, all 3 sides are labeled, you jump right into Pythagorean theorem. So I have I did that wrong. This should be C, because that's the hypotenuse. And then A and B, pick which one you want to be which. So then it would be 3 squared plus the square root of 5 squared equals x squared. Again, I caught myself because you want to make sure the hypotenuse is C. So this would be 9 plus 5 equals x squared. 14 equals x squared. X equals the square root of 14. Great. So again, the prerequisite information you guys need to be successful with Pythagorean theorem is know how to simplify square roots, how to do basic algebra solving that involves squares, order of operations, things like that. And then also some little details about how to distribute squares when you have square roots and how the square and the square root cancel each other. So if you still have a little bit of shakiness with those algebra concepts, please make sure that you're reviewing them so you can be successful with this concept. Now on the second page, on the very, very top, the last thing we're going to talk about for the Pythagorean theorem is how to use the Pythagorean theorem with word problems. And then we're going to transition into using the converse of the Pythagorean theorem. Excuse me. So for each one of these word problems, they don't have a diagram drawn for you. Sometimes they do have a diagram, sometimes they don't. If they don't have a diagram, definitely make sure that you draw one yourself. So in this scenario, it says the length of each side of a baseball diamond is 90 feet. What is the distance from the home plate to the second plate? So we're going to be drawing a diamond. So I have a diamond, this. For a diamond, all the sides are the same. So I have 90, 90, 90, 90. Now you do have to have a little bit of an understanding of baseball field. This is home plate right here, and second plate is right here. So we're trying to find this distance. Okay. Now something else that's important to remember about a diamond, it's basically a square that's kind of been turned, so it's the pointy parts are up instead of flat. We usually draw a square like this. So a diamond is basically a square that's been twisted. So you do need to remember that we have 90-degree angles in the corners, also up here, but those aren't relevant. I'm not going to make the picture too complicated. So all four corners are 90 degrees, but these corners are more relevant because if you guys see that line that I just drew from home plate to second plate, that actually divides the diamonds into two equal right triangles. And so that's how I know I'm going to be using Pythagorean theorem, because if I go off to the side and draw just one of them, I have 90, 90, and then the side I'm looking for, which is this one right here down the middle, I'm going to call that x. So now I can see I have a right triangle with all three sides labeled. I can use Pythagorean theorem. So my formula would look like 90 squared plus 90 squared equals x squared. We have A, B, and C. C is the hypotenuse. So then that's going to be a big number. 16,200. When you find both of those squares and then add them together, you get 16,200. Now, if you take the square root of that, that's going to be a really big number to try to simplify. So I'll give you guys a little bit of a grace when you guys are doing word problems. I'm okay with decimals. Okay. On the previous page, when they weren't word problems, I expect to see simplified radicals. But in the context of word problems, if you guys get a huge number that you're supposed to be taking the square root of that number, you can give me a decimal. Only in the context of word problems. So if you guys use your calculator to find the square root of that huge number, it's about 127.3. So you guys are allowed to use decimals in the context of word problems when you're taking square roots. I'm fine with that. All right, what about this one? This time we have a ladder that is placed 2 feet from the base of a house. So I'm going to draw, that's a house. Whatever, you guys can be as artistic as you want. Here's the door, here's the window, I don't really care. So you have a house here, the ladder is placed 2 feet from the base of the house. So it's leaning, the ladder leans. It does take a little bit of context clues in the question to draw the picture. So a ladder leans, so the base of the ladder is 2 feet out, and the ladder itself is 25 feet long. And I want to know how high up on the house it would reach. That's my situation here. So obviously a house has to be perpendicular to the ground, otherwise it would fall over. So we're allowed to assume that this is 90 degrees where the house intersects the ground. So if you guys go off to the side and draw a right triangle separately, I can see that this represents the house, the ladder, and then how far the ladder is from the house. So I have 2 here, 25, and then what they're asking me is how high up on the house the ladder reaches, so I can call that side x. So within this diagram, I actually have a right triangle with 3 sides labeled, with the x being the one I'm looking for. So again, Pythagorean theorem. So I have A, B, and C, so I have x squared plus 2 squared equals 25 squared. X squared equals, what is that number? 621. So again, I went ahead and found 25 squared and then subtracted 4. So that gives me 621. And then again, because it's a word problem, you guys can just take the square root of that in your calculator and give me the decimal, which is approximately 24.9. Don't give me rounded whole numbers. I do want to have a decimal if you guys are doing this, a decimal with at least 1 decimal point. You guys can give me to the thousands if you'd like, but at least 1 decimal point is what I'm looking for. All right, and then the last one, it says a plane leaves London going 15 miles north. Another plane leaves going east for 10 miles. How far apart are the planes? So I'm going to say this dot right here is London. Okay? I have one plane that's going north. Okay, so one plane went north for 15 miles. Then another plane leaves going east for 10 miles. Whatever So northeast. So then I have this little line right here. This is going to represent how far the planes are from each other. Okay? When you guys are talking about distance, it's a straight line from one point to another. So this line right here represents their distance. Now, on a compass, the directions, north, east, south, and west, they're all they're perpendicular. The north, south, and the east, west are perpendicular. So you can put a right angle here. And then this is the distance I'm looking for, x. So again, we have a right triangle with all three sides labeled. So I can use Pythagorean theorem to solve it. So I would have A, B, and C. So 15 squared plus 10 squared is equal to x squared. Again, it's going to give me a pretty big number. So I have 325 equals x squared when you add those two numbers together. And then again, because it's a word problem, you guys can give me a decimal. So if you take the square root of that, it is approximate, I think on my notes I have approximate 18.0. I can't remember if there's another number that comes after the 0. If it's a whole number, you can give me a whole number if it's a perfect square. But if you do have another decimal after that, you can definitely do that too. So, this is what you would write as your final answer. Okay? So those are word problems where you guys would use Pythagorean theorem. And it may not be obvious to use Pythagorean theorem, that's why you guys have to draw the picture first and then see what information you have. Is it a right triangle? Do you have something written for all three sides? If that's the case, you can use Pythagorean theorem. Alright. Last thing we're going to talk about a little bit more quickly is the converse of the Pythagorean theorem. So what's really cool about this is you can switch the Pythagorean theorem around, the converse, which if you guys remember, it's switching the hypothesis and conclusion. If I start with the square of the longest side of a triangle being equal to the sum of the squares of the other two sides, then I can say that the triangle was a right triangle. If you remember, Pythagorean theorem starts with it being a right triangle first, and then you get a squared plus b squared equals c squared. If you go the other way around, if you have a squared plus b squared equals c squared, then you can say the triangle is a right triangle. So that really comes in handy when we're looking at triangles like these, where I don't have a right angle drawn into the picture, and I'm trying to decide if it's a right angle at all. So these triangles appear to be right triangles. They look like they are, but remember, the biggest thing that you guys could mistake is when you're looking at a picture is just assuming that it's a right angle, and you never want to do that. So they appear to be right angles, but we're going to prove that they are, or not, or prove that they're not. So for this one right here, you have to be careful. Look at the language. It says if the square of the longest side, they can't call it a hypotenuse in the converse because it wouldn't technically be called that if it's not a right triangle. So we use the language longest side. So the longest side is 11 here, so we're going to call that C for our theorem. And then we have A and B. So if I do 9 squared plus 10 squared, is that equal to 11 squared? That's what we're trying to figure out. So I would have 181 if I add those two. And then 11 squared is 121. So I can see that those actually are not equal. So if these two are not equal, then this is not a right triangle. Okay? So this one right here is not a right triangle because the Pythagorean theorem, it didn't work out. The sum was not equal to the longest side squared. Well, what if we try it with this one? I can see that the longest side is 8 times the square root of 2. I don't know exactly what that is as a decimal, but you guys can test it in your calculator to make sure it is in fact greater than 8. This is going to be the biggest side, that's going to be my C. And the other two are A and B. So I would have 8 squared plus 8 squared. Is that equal to 8 square root of 2 squared? Remember, parentheses around that. So I would have 2 times 64. Where am I? There I am, which is 128. So if you do 64 plus 64, you get 128. And then I want to know if that's equal to what this is. So if I distribute the square, I would have 64 times 2, which is also 128. So in this scenario, they were equal. The Pythagorean theorem did work. So if both of these values are equal to each other, then you would say, yes, it is a right triangle. Right? So that's how you guys can use the converse of the Pythagorean theorem to determine if something's a right triangle or not. Alright. However, that begs the question. If our first triangle that we had over here was not a right triangle, then what kind of triangle was it? So we can actually take that idea and extend it to figure out what kind of triangle it is. If it's not a right triangle, is it acute or is it obtuse? we actually have a little key that we can use here, some rules that we can use. So obviously if a squared plus b squared equals c squared, that's what we've been talking about, then it's a right triangle. Right? That is the converse of the Pythagorean theorem. We just talked about that. However, if it's not equal to, you guys can use inequalities where you're comparing whether the sum is greater than or less than c squared. So if the sum, or I'm actually going to change how I refer to this. If the longest side squared, if c squared is greater than the sum, that makes it an obtuse triangle. So if that one longest side is bigger than the other two added together when you square them, then it's obtuse. But if the longest side squared is smaller, that makes it acute. So focus on the longest side. If the longest side is equal to the sum, it's a right triangle. If the longest side is bigger than the sum, it's obtuse. If the longest side is smaller than the sum, it's acute. Right? So we're going to test that out with these examples here, and then that will be it for our lesson today. So we're going to decide whether the numbers would create a triangle. So that's the first thing that we're going to do. If you guys remember from one of our previous units, we talked about how to decide if numbers will create a triangle, and I'll review that in just a second. But if we decide that those numbers would create a triangle, then we would decide what type of triangle. Alright, so this idea that we talked about before, to decide if three numbers will create a triangle, you always circle the largest side, you add the other two together, and you want to make sure that that number is bigger than the biggest side. You guys remember that. There are no squares in this. This is what gets a little bit confusing. The process is going to seem very similar, but one part doesn't involve squares and the other part does. So without squaring anything, if you add the two smaller sides together, the 8 and the 7, which is 15, because that's greater than 9, that means it is a triangle. That's just the first step. So these would create a triangle. Now, we need to figure out what type of triangle. When you've confirmed that it is a triangle and now you're transitioning into what type of triangle, that's when you bring in the squares. So now I'm going to do 8 squared plus 7 squared and see how that compares to 9 squared. Well, 8 squared plus 7 squared, let's see what I have here. That is 113. Okay? And then obviously we know that 9 squared is 81. Okay? Now, 81, that was the square of the longest side. Because the longest side squared is smaller than the sum, that would make this an acute triangle. So one more time, you're going to identify the longest side. You're going to add the other two together and make sure that it's bigger than the longest side. Once you've said yes, it is a triangle because that's happening, you're going to do the same thing, but now you're going to square. You're going to square these two sides to find out what type of triangle. So you do 8 squared plus 7 squared, that gives you some number, in this case it was 113, and then you compare that to the longest side squared. If this is smaller, it's acute. If it's bigger, it's obtuse. If they're equal, it's a right triangle. Okay? So let's try example B. So again, the longest side is 14. When I add 4 and 10, that equals 14. That can't happen. For it to be a triangle, the sum has to be bigger than the longest side. So in this case, I would say it's not a triangle, and so if it's not a triangle, it obviously can't be acute, obtuse, or right. So if you determine that it's not a triangle in the first place, you just write no and then move on. Okay? Alright, over here the longest side is 7. So when I add 4 and 5, I'm going to use a different color just so the work doesn't get merged. So when I add 4 and 5, that is 9, and 9 is greater than 7. So yes. Do that so you know it. So yes, it is a triangle, because the sum of the two shorter sides is greater than the longest side. Once you've confirmed that it is a triangle, to determine what type of triangle, now we're going to throw the squares into the mix. So I'm going to do 4 squared plus 5 squared, which would be 16 plus 25, which is going to be 41. We're going to compare 41 to the square of the longest side, which is 49. Because the longest side squared is bigger than the sum, that makes this obtuse. Okay? So if this is bigger, the c squared is bigger than the sum, it's obtuse. Alright, for the next one, the longest side is 145. When I add 144 and 17, obviously that's going to be bigger than 145. Okay, so that sum is bigger than 145. That means we have a triangle that we're working with. So what kind of triangle is it? So once you're trying to decide what kind of triangle, now you're going to square the numbers that we were just working with. So I'm going to square 144, I'm going to square 17, which gives me quite a large number, 21,025. Okay. Then I'm going to compare that to 145 squared. If you type that into your calculator, you'll actually get that that number squared is also 21,025. So because those two numbers are equal, that means that it is a right triangle. Again, when they're equal, it's a right triangle. When the c squared is larger, it's obtuse. When it's smaller, it's acute. Okay? All right, last two really quick. All right, so when we have square roots thrown into the mix here and you're not quite sure whether the square root of 5 is bigger than 5 or 6, go ahead and stick it in your calculator to find out what the decimal version would be. The square root of 5 is actually smaller than 5 and 6. So my largest side is 6. So when I add 5 plus the square root of 5, is it larger than 6? Yes, it is. And you can verify that in your calculator. When you add 5 and the square root of 5 together, it'll give you a decimal, but that decimal will be greater than 6. So that means I do have a triangle. Now I have to figure out what type of triangle. So now I'm going to take the exact same sum, but I'm going to square the numbers. So I'm going to have 5 squared plus the square root of 5 squared, which would give me 30, because this would be 25 and that would be 5, so 30. And then when I square 36, when I square 6, I get 36. So because the longest side squared is bigger, that makes this, obtuse. Call it a no. Okay, because c squared was bigger, it's an obtuse triangle. All right, for our last one, the longest side is 12. When I add 8 and 9 together, that's 17, which is larger than 12. So that means it is a triangle. So I have a triangle. Now, what kind of triangle? You have to square. So I'm going to take the same numbers here, and I'm going to square them. So 8 squared plus 9 squared, that's a big number too. That's 145. I'm going to compare 145 to 12 squared, which is 144. Because this side side squared is smaller, that means that the triangle is acute. Right? So it does require a little bit of memorization is what I was going for. It does take some memorization to remember what scenario is which, how to know it's acute, obtuse, or right. So do make sure you guys memorize this chart. Also memorize the difference between when you're determining if it's a triangle in the first place, which does not involve squaring, and when you're trying to determine what type of triangle, which does involve squaring. Please make sure you know the difference and how to apply them in different contexts. That was the end of day 2 for Unit 7. For the remainder of class, you guys will want to go ahead and start working on your homework or continue working on Spiral Review 6. Remember, Spiral Review 6 is going to be due on the 23rd, so it's going to be next class. So please make sure that it is done and ready to be turned in. I'm sorry I'm not here to check your answers. If that's something you would like to do before you turn it in, you can come see me at some point before 6th period on the 23rd and I can check it for you. Otherwise, you guys can get out your laptops, or if you've printed out the homework, go ahead and start working on that. Please be respectful of other people's time, and please make sure you guys are working the entire time until you're done. There is an answer key as well, so please make sure once you finish working, you check your answers and correct any mistakes. If you have any questions, I'm sure that you can work together with somebody next to you using the process that I showed you guys when we came back from break on how to work collaboratively. So please make sure you guys are staying productive and getting your work done. We will have a quiz on this lesson when you guys come back next class, and I expect you guys to have the homework done so you're prepared for that.